Hey grade 11s, today we're going to solve quadratic equations by graphing. So of course the main tool that we use to graph is either the graphing calculator or Desmos, depending on which tool you have most readily available to you. Okay, so I'm going to model using the graphing calculator. You can use Desmos though if you want to do that too. So, example, the flight of a toy rocket depends on the initial velocity of the rocket, the height of the rocket, ht in meters after t seconds is given by the function. H of t equals negative 4.9 t squared plus 60t plus 1. How long is the rocket at or above 50 meters from the ground? So here's what we know. I don't even have to plug any equations in. Here's what I know. I know that a rocket's probably going to go something like this. It's going to go up. It's going to come down. And I know that I want to know when the rocket is at 50 meters. So I want to find out this point and this point. This is not a graph, this is a sketch, but it'll help us out. It'll help us out because we'll know that the first equation we're going to enter into Desmos or the graphing calculator is negative 4.9 x squared plus 60x plus 1, and y2 is equal to 50. Okay? Okay. So, what we need to do is we need to use the appropriate graphing tool and figure that out. So I'm going to go to graphing calculator. Graphing calculator, I've already typed in those equations here. I've already come up with a window. So if we look at the graph, this is what we see. Now we can go second, calc, intersect, first curve, second curve, so enter, 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 gives us this time right here, which is 0.87, 989, 412, and 50. We should record all the decimal places we can. So that's 0.87, 989, 412, and 50. And then we want to find the coordinates of the second intersection point. So we go second calc, option 5. Because we want to find the second intersection point, it's important for us to move the cursor closer to where the second intersection point lives. So that at least means we should go over the maximum. I'll go a little further down, and then I'll tap, tap, tap again, and we get 11.365004. So we get 11.365004 and 50. So those are the two times. The time when it's coming up and the time when it's coming down. So to find out how long it's in the air at that height, we're going to take 11.365004 and subtract 0.87989 412. And when we do that, we get 10.49 if we round to 2 decimal places. And we should round everything to 2 decimal places. So 10.49 seconds. Okay? Okay. Next example. Natasha's uncle wants to run 24 meters of fencing around his rectangular garden using the side of the house as one side of the garden. Write a function for the area of the garden, A in square meters, in terms of the width of the garden, which is W in meters. So all we really need to do is understand that we don't need fencing right here because it's against the house. We can call this the width, which also makes that the width. And if we have 24 meters of fencing, then the length is just going to be 24 take away 2W. Now, using that idea to figure out the function, it's going to be A for area. Area of a rectangle is length times width. The length is 24 minus 2W. The width is W. That's all there is to it. Now, find equations where the area is 40, 64, and 80 meters squared. So 40 equals 24 minus 2W times W. 64 equals 24 minus 2W times W. And 80 equals 24 minus 2W times W. Really, to answer these questions, what we have to do is we have to associate one side of the equal sign as your y1 and one is your y2. So I can set y1 equal to 24 minus 2x times x, because again, we have to use x's and y's, and our y2 equal to 40. Okay, I can do that. So let me get the graphing calculator here. Go to it here. 24 minus 2x times x equals 40. If I go to my window here, I'm probably going to go, x has to be positive. There's no such thing as negative width. So we can go from -2 to probably no more than like 24 for sure. Go up to 30 though, really doesn't matter. Scale can go up by 2 probably. For the y-axis, negative area doesn't make sense. But the biggest area that you could probably get would be about, I don't know, say even 100 or no, say 200. Go up by 200 is fine. So we hit graph here. There's the one. Okay. And there's the other. Wow. So we have 2 intersection points. I also see that I can really limit my other values here, but I'm not going to bother at this point. I just want to find out what those intersection points are. So to find out those intersection points, again, we go second calc, option 5. And what I'm going to do is I'm going to use a smaller value here. Going to use a smaller value here. Get close to that first point. Enter, enter, enter. And we get the point 2 and 40. So 2 works. 2 works. And I can do it again. It's a nice friendly number, so I can remember 2. If it was 5 decimal places, I couldn't remember it, but press enter, enter, and we get 10. 10 also works. So going over here, to give us an area of 40, 2 and 10 both work. In fact, you can have a 2 by 10 garden or a 10 by 2 garden. And really, those things are identical. So by figuring out both of those intersection points, what we're really doing is we're only finding one combination, and that combination is a 2x10 garden. Because technically we associate the longest side with being the length and the shortest one with being the length. So a 2x10 garden would give us an area of 40. Okay? Now we're going to do the exact same thing, except we're setting it equal to 64. So we're going to go back to the graph here, and we're going to make this y2 equal to 64 now. And now we're going to hit graph. Okay, still goes through twice. Second calc, intersect. Make that value a lot smaller. I'll go with this one first. Here, here, here. 8 is the biggest value. And I'll go back towards the left one. So we get 8 and 4. 8 and 4. 8 and 4 work. So going back here, 8 and 4 work here. So I'm going to get an 8x4 garden. Now this is a little bit different because we only have 24 meters of fencing. So the 8x4 garden would, let me think here. If that's 8, then that's 8. Interesting. No. If W is 8, then that's 8. That's a lot, isn't it? No, it isn't. No, it works. It works. It works nicely. It works nicely. So, no, it does work, actually. Just thinking about it. Yeah, it works. Actually, we're going to go back to the first one in a second here. But if we use 8, if we use the 8 solution we got, then actually it's going to be an 8x8 garden. Because that makes sense, because 8 times 8 is 64. Now, the other one we got was 4. So if we plug in 4 for W, what we're going to get, that's not what I want. If I plug in 4 here, that means that's 8. So this whole thing is 16. So that gives us a 16. How do you make a 16? That's how you make a 16. So that gives us a 16x4 garden. Okay? And going back to that first combination, I've been doing this a while, guys, here today, and I feel like junk. So we got 2 and 10 as our possible solutions. When W is 2, this whole thing here is 20. So that means we're going to get a 2x20 garden, which makes sense because that gives us an area of 40, which is what that was. And when we have 10, if W is 10, then if this is 10, then that's 20, which makes that 4. So we get a 10x4 garden. So a 2x20 garden or a 4x10 garden give us an area of 40, which is that first combination. An 8x8 garden and a 16x4 garden give us an area of 64. And last but not least, we need to look at this one where we have an area of 80. An area of 80. So when we have an area of 80, we got to plug in 80 for our y2. When we plug in 80, though, we're going to see something a little crazy here. What we're going to see is that red line is above the curve. They don't meet. They don't meet. So what does that mean? Well, quite frankly, it means you can't have a garden with an area of an 80. So no such garden. No such garden. So there's 4 possible configurations. These 2 possibilities that give you an area of 40, and these 2 possibilities that give you an area of 64. Okay? Sorry to kind of muddle through that a little bit, but okay, one last example, then we're done. Find the roots of the quadratic equation 4x squared minus x minus 30 equals 6x times 3 minus x. So this is the exact same thing. This is the exact same thing as what we did before. We're going to let one of these be our y1, one of these be our y2. Find out where these intersect. All right? So if I'm using Desmos or my graphing calculator, I got to show my work. So y1 is equal to 4x squared minus x minus 30. y2 is 6x times 3 minus x. And it's just plug and play. All right? So 4x squared minus x minus 30. So here's the graphing calculator. I'm going to clear these out. So there's my 4x squared minus x minus 30. My y2, I forget what it is. I got to check again. 6x times 3 minus x. Don't have to simplify it. Just write it exactly how it appears. Okay? Exactly how it appears. So those are our 2 equations. Now, for our window here, we should probably go for the standard. So to kind of do that quickly, I can just go zoom 6, the negative 10 to 10, negative 10 to 10. But when I do that, I see this. So when I see this, tells me a few things. My x values are fine, but my y min and y max has to get bigger. So I'm going to go to my y min. I'm going to make it really big. Well, not really big, but big enough. Let me make that negative 30. I don't want to go looking for it. I'm going to make this positive 30. I might as well go up by 3s here. And then hit graph again. Then hopefully I see both vertexes, barely, and some points of intersection. There we go. Good enough for me. Good enough for me. So we see the points of intersection. That's what we're really interested in. Points of intersection. This one here. This one here. So you just have to find both of those points. And of course, how we do that is using the intersect tool. So second, calc, intersect, and we're kind of down towards the bottom one, so just go enter, enter, enter. Negative. Now we're looking, we don't really care about the y values, we just care about the x values. And we're not going to do anything with these, so we could just round these to 2 decimal places right off the hop. So what we're really interested in is the negative 1.02, which is rounded to negative 1.03. So x equals negative 1.03. And the other solution, which we can find by going second, calc, intersect, enter, enter, 2.93 if we round. 2.93. Now, what does it mean when it says to verify your answers? How do we verify the answers? Well, what you would need to do is to plug in both of those x values for both x and see if you get left side equal to the right side. That's what you got to do. And so you could just figure that out. So left side equals, and we could do this on the calculator too, which is nice. 4 times negative 1.03 squared minus 1.03 minus 30. So just plug that into the calculator. get an answer, and then do the same thing on the right side. 6 times negative 1.03 times 3 minus negative 1.03. So if we plug it into the calculator like this, let the calculator do all the work. These two numbers here should be the same, or very close. Because we rounded, they're not going to be exactly the same, but they should be very close. Okay, they should be very close. And you can repeat with the other one as well. Okay, all right, there you go. Do questions 1 to 13 on pages 379 to 381.